right, my friends, someone asked about problem 14 here, partial fraction decomposition. I don't know for sure that I'm going to be able to fit my big bubbly writing here on this paper. So so I'm going to get some scratch paper to write on. Anyway, okay. So let's see. For part A, it says x plus 7 over x squared minus x minus 6. You're going to factor the denominator. And then partial fraction decomposition is where you try to figure out what fractions did they add together to get this to be their answer. So one denominator would be x minus 3, another denominator would be x plus 2. And since these are linear, you would have constants that would be on the top. So A and B represent arbitrary constants that I need to solve for. The next thing you're going to do is actually your thought process is kind of like, how do I go backwards? How do I add these together to get this to be my answer? The answer is you get common denominators. So you would take A over x minus 3 and you'd multiply it by x plus 2 over x plus 2. You'd take B over x plus 2, you'd multiply it by x minus 3 over x minus 3. And then what would you have? You would have A, so I'm going to distribute this A in. You'd have AX plus 2A over this denominator. And then you'd have plus, I'm going to distribute this in, BX minus 3B over, and if you multiply these together, you would get this denominator. So I'm going to go ahead and just say like that, okay? So with partial fraction decomposition, I think of it as winning 2 battles. Battle number 1, make the denominators match. Always do that first. Once you make the denominators match, you just need the numerators to match. So you need x plus 7 to be equivalent to this. So I'm now going to say this would yield that x plus 7 must equal. And I'm going to take this expression, grouping the x terms together. AX and BX are x terms. And then I'm going to group the non-x terms, 2a and negative 3b together. I'm also going to factor the x's out here. Of the x terms, I'm going to put it on the right side. And I'm going to just put parentheses around. This is more steps than you really need, but I'm explaining it, assuming that someone might need some extra explanation here. So now let's look at the left side. You have 1x plus 7 on the left. So that means if these are really truly going to be equal, then the number of x's on the left would have to equal the number of x's on the right, which means a plus b must equal 1. And 2a minus 3b must equal 7. So your constants equaling your constant here. All right, my friends, so now to solve the system of equations using whatever method makes sense to you, substitution, elimination, what have you. When the first one's simple, sometimes I'll just use substitution. So A is equal to 1 minus B, for example. So then if you take that and sub it in here, you'd have 2 times 1 minus B minus 3B equals 7. So you'd have 2 minus 2B minus 3B equals 7. So you'd have negative 5b then would equal, I'm going to subtract the 2 over 5, so b is equal to negative 1. Okay, so now that you know what b is negative 1, you could back substitute that in, boop, right there. So that means a must equal 2. So at that point, you could take your a and b values and back substitute them all the way back up into your form. So A we found to be 2, B is negative 1. So your answer is, hey, if you've got x plus 7 over x squared minus x minus 6, and you want to know what 2 fractions were added to get it, here they are. You'd have 2 over x minus 3 plus negative 1 or minus 1 over x plus 2. There we go. How to unadd fractions, also known as partial fraction decomposition. Okay, that's just part A though. Part B, I wanted to give you some practice with the special forms. So the first one is just kind of like the process in general, where you have distinct linear factors. Part B, notice that, let's factor the denominator. So you end up with what's called a repeated linear factor. So the form in that case would be x minus 1 would be one of the denominators. And I hope it makes sense that the other denominator cannot also be x minus 1, because your least common denominator in between these two is just x minus 1. It's not x squared minus 2x plus 1. So what we do with the repeated linear factors case is we have one be just the base and the other one is the entire denominator there. And then, so this is linear, so you'd have a constant on top. The base here is linear. I know the whole thing isn't, but the base is linear, so you'll still have a constant on top. So this is your form. Now, once you have your form, it's just like the last process we talked about in part A, where you try to win the denominator battle. To win the denominator battle, make sure that you're going for this denominator. So you don't want to go for x minus 1 cubed, which is a common mistake here. So you're going to take a over x minus 1, you're going to multiply it by just x minus 1 over itself, not x minus 1 squared. And then you're going to take b over x minus 1, quantity squared, and you're not going to multiply it by anything because it already has this denominator that you're trying to get. So now I have ax minus a plus b over x squared minus 2x plus 1. So denominator battle, fought and won. Numerator battle, now that we have the denominators matching, now we're going to make sure that 2x minus 3 is equal to ax minus a plus b, which means that a would have to be 2, and negative a plus b would have to be negative 3. Since a is 2, the second row would say negative 2 plus b equals negative 3. Add the 2 over, you end up with b being negative 1. Just like last time, you're going to take your a and b values and then you're going to back substitute it into your form. And then that would lead to your final answer. So our conclusion here would be that 2x minus 3 over x squared minus 2x plus 1 is equivalent to 2 over x minus 1 minus 1 over the quantity x minus 1 squared. There we go. Okay.